Hi, we are going to talk about one restful workstation that takes place in Black Hawk, Mexico. We are Team H and we are integrated by Andrés Bustos Durón.
Rogelio Gaona Sánchez.
Jennifer Raquel Maldonado Saldaña.
Juan Vargas, Herrera.
Okay, let's begin. History. Nowadays, Black Hawk de Mexico is a great ductile iron foundry, part of Grupo. They are specialists in the manufacture of components for medium and heavy-duty trucks, agricultural tractors, and implements like brakes, heavy-duty machinery, hydraulic components, and other industrial applications. They manage three types of nodular iron: ferritic, ferritic perlite, and two types of gray iron, 35 and 30. Okay, to the history, Blanco de Mexico in 2001 is formed as a joint venture between Black Hawk Foundries and Emerson Electric Company. In 2003, Grupo Quinto acquires 100% of shares of Black Hawk de Mexico. In 2005, more value-added operations are included, such as machining, painting, heat treatment, and sub-assembly. In 2007, lean manufacturing methodologies are learned and applied by everyone in the organization. In 2010, strategic capital investments are made which allow becoming a more flexible foundry. In 2013, this is a special year. They start the installation of line 2 for no-bake molding. This line is inaugurated in 2014. On this line, Black Hawk produced big and heavy iron pieces for John Deere, CNH USA, Systemex, and just to name ones. This project consists in the analysis and evaluation of a video where the worker is in danger of suffering a CTDs, which are diseases that affect the worker's performance. Finding the solution to this situation, we are going to take and use ergonomic tools such as RULA and Rogers. The product. Black Hawk de Mexico is specialized in nodular iron, and their main products are the Carrier 3200 and 1704. This product is a brake bracket. It helps to join a full brake system assembly that is made in Systemex. This product has a demand of 2,225 carriers per day. If we do not fulfill the demand, Systemex will stop their production. Technical description are: weight is like 47 kilograms, radius of 15 centimeters, price is $33 approximate, and it is made in the FBO5, biggest mold line in Black Hawk. Well, why we choose this process? As you can see in the image, this image is a list of assistants of May 2019. Workers who had the attendance in the pour the metal in the mold are the ones who lead the absenteeism of the area. They represent more than 80% of absence for mold, but for mold area, and two workers quit recently. The area covered this immediately, but sometimes the same manager has to do this process. So why they have to do that? Let's see the video to understand why the pouring metal is the main problem. Okay, let's explain the process. The iron arrives on a big industrial pod. This pod can fill up two containers for each operator of the line. There are three lines every line has two workers. As you can see in the layout, the work environment consists in one machine, FVO5, and the worker has to fill every mold throughout the aisle. It is such a risk that operator walk beside a half-ton metal container with a temperature of 1200 degrees through the aisle.
And analyzing the video and using the register ergonomic tool, we grade as follow. In the neck, we saw that it does not make a great effort and it was qualified with 211 with a priority of 3, which means low. The shoulders exert a force on the head, remain in that position for 15 seconds with a frequency of 14. That is why it is classified with 3 to 3 with a priority of 10, which means very high. The back leans forward and exerts strength with light duration, a moderate frequency with which a score of 211 was obtained, and its priority was for low. The arms and hands exert great forces with a rotation. In the video is seen where the worker hangs on the wheel to turn it. This action is performed 14 times and lasts 15 seconds. The rating we gave was 3 to 3, giving a priority of 10 very high. The legs do great forces, pushing the molten steel around 7 seconds. With a heavy repetition, this reserving a score of 3 to 3 with priority equal to 10, very high.
The second tool we have used to analyze this activity was rapid upper limb assessment. The arm is over 90 degrees, the shoulder is elevated, and the arm is extended. That's why the value is 6. The forearm is separated from the body and also extended almost all the time. That's why the value is 2. The wrist is over 15 degrees and is flexed on the middle line. The value is 4. The wrist is on the average range of rotation and the value is 1. With these values and the help of the table A, we got the value of 9. Like the activity repeated plenty of times per minute, we add 1 to this value. Like the mold is heavy, we add a 3. Sometimes the worker looks down. This has a value of 3. The worker stays straight with a lateral inclination. The value of this is 2. The worker jumps while doing the activity. That's why the value is 2. With these values and with the help of table B, we get the value of 4. He doesn't stay calm, so we add 1 point. The mold weight is over 10 kilograms, so we add a 3 points. With these values, we search on table C and we get a final punctuation of 7. This means that the activity is too dangerous and we have to modify the workstation immediately. With Rogers, we realized that the main areas affected are shoulder, wrist, hands, fingers, arms, elbow, leg, knees, ankle, and feet. With the second ruler tool, we can confirm that the activity is dangerous, risky, and can cause CTDs such as rotator cuff tendonitis, cubital tunnel syndrome, and Guyon's canal syndrome.
Improvement of work area, we choose to place a hoist which must withstand more than 1 ton. This tool will help use to prevent the worker from suffering the lifting the molten material manually, since with hoist he will only have to use the control of the tool or to raise or lower the wheel with the molten material, and will and which will help use to avoid risk and disease to workers. The following image shows the comparison of the work area before and after if the improvement was to be placed.
With the improvement, we eliminate the probability to suffer an upper arm injury, eliminate fatigue, give a better handle with the container. The worker does not need to be closer to the mold to do a correct pouring. Some kind of muscle injuries, such as cramp, sprain, tear, it's there.
Cost of the improvement is approximately more than 600,000 Mexican pesos, which will involve the purchase of 3 hoists plus the cost of their installation. However, this investment will bring us many benefits such as reduction of abstinence, reduction of personal rotation, quit compensation, since in the past month, three was an abstinence of 3% of workers and unreceived B2.
In conclusion, it's important to always look for the worker's health to prevent injuries and CTDs on every worker. That's why we need to know how to use all the ergonomic tools and how to read the information of the tables to look for solutions and improvements that makes easier the activity and eliminate risks for the workers. Everybody needs to understand that the money is not everything, because if the workers are not comfortable or they feel that their life or health is danger, they are going to quit and the company will suffer a lot of absenteeism or personal rotation. That means they have to pay staff training or injury compensations. It's better to always look for the workers' health and keep them safe. Making this project help us to evaluate a real situation of a company with the help of ergonomic tools we have seen along the semester. It's important for us to be familiar with these tools because in the future we can apply them in our work.